Now let's consider an extended example that walks us through a set of business choices and deployment considerations. It starts with an initial deployment in a project and the default network. Our business is in Europe, so we begin deployment in a European region and zone. The application has a public front-end web server and a private back-end server that implements our application's business logic and is only accessible from our front-end web servers. In the initial deployment, we choose to place the back-end server in the same region, on the same subnet, and in the same zone as the web server because it offers us the lowest latency and no egress charges. Next, our company is expanding into the US. We want good performance for our clients, so we are setting up a web server near them. At first, we thought we would set it up symmetrically with our European deployment, as shown in this diagram. However, as the business grew, we realized that availability of the back end was critical. To enhance it, we moved the back ends into separate zones from the web servers and put them behind a shared load balancer. If either went down, the other one could keep serving both front ends. Remember, cross-region traffic doesn't require a VPN as the GCP network spans regions, unlike an AWS VPC. Similarly, we could put the front ends behind a shared load balancer of their own. With this setup, we could suffer any one front-end zone outage and any back-end zone outage and still keep our application running. In addition, users could share a single global IP address with traffic still routed to their nearest front end. As the company grew further, the US team wanted to support other applications on non-predefined IP addresses and keep their traffic completely separate from the European team. So we moved the US resources to a separate network. This made it a little easier to ensure that the teams only had resources on their own networks, not the others. Since they already had IP addresses assigned in ranges other than the default network, we set it up as a custom network instead of an automatic network. However, load balancers don't span networks, so they would lose their redundancy unless they chose to set it up again in each network. Later, an integration project made it necessary to bring private IP connectivity in from an external network. Because latency to the US happened to be more critical, we terminated the VPN in the US on a subnet whose IP addressing we explicitly specified to ensure no range collisions with the on-premise network. Because we were using a custom network, we could add a subnet with matching IP range immediately. As the business continued to grow, our cost accounting got more sophisticated, and we needed to split administration and billing between the two regions. So we moved the US and European resources into separate projects. GCP also offers cross-project networking that allows resources in a single network to be shared across projects for separate billing or access control. This feature is out of scope for this course, so see documentation for details. By the way, in these examples, we scaled up rather than out. GCP customers commonly use autoscaling and managed instance groups to scale out instances within a region. These topics we covered in a previous module. In summary, most of the networking entities in Cloud Platform, such as load balancers, firewall rules, and routing tables, have global scope. More importantly, networks themselves have global scope. This means you can create a single private IP space that is global, without having to connect multiple private networks and manage those spaces separately. In addition, GCP subnets are tools for administration and complete traffic separation rather than for traffic locality. Resources can be on the same GCP subnet, but in different regions or zones. And finally, GCP networks are a property of the projects in which they were created. For traffic to pass between networks associated with different projects, it must traverse the Internet, a VPN, or else the new GCP cross-project networking feature. Now let's configure a custom network and subnet with a custom IP range, a public front end, a private back end, and a firewall between the two.